Here are the answers to the first part of the investigation. If you look at A, the function is both continuous and differentiable at 2 because we can draw a tangent there. If you look at B, it's continuous but not differentiable because while we can drive over it, you can't draw a tangent at that point, so this refers to a cusp. Moving along, C is actually impossible. There is no way to draw a function that is differentiable, but it is not continuous. If it's differentiable, it must be continuous. Part D, I realize you might not know what smooth means. Smooth basically means that it's not pointy, which means it's not a cusp. And so something that would work here is this. Look at this graph. It goes vertical just for an instant, and then it levels off. Because if we have a vertical tangent, recall that a vertical tangent means that f prime of 2 is undefined. Moving along, for E, it has a limit, but it's not continuous. It could look like this. There could be a hole. There could also be a hole with a point somewhere else, but not actually on the curve. And then finally, is continuous but does not have a limit. That's impossible, and you know that from looking at the definition, because the definition of continuity says there must be a limit. So we come down here. Here's what we figured out. If f is differentiable at a point, then it is also continuous at that point. And we know that if it is continuous at the point, that means that it has a limit. So differentiable implies continuous, and continuous implies limit. When you got that written down, what I want you to do is go to the next page, and the next page is going to look at differentiability, but this time on an interval. Okay? And so we're going to define that as long as you can draw one unique tangent at every point on that interval, you know that it is differentiable on that interval. So what I want you to do is I want you to work through all of part 2, which would be this page right here, and then when you get to the bottom, I want you to go